Now, in this question, we have six registers connected in a way, and we have to find the equivalent resistance between A and B. That is the first part of this question. Okay, so we have to find how much is the resistance from here to here when this third terminal is left open, left floating. Okay, to solve this, let me first make a copy of this circuit. Okay, so here is the copy of this original circuit, and now this third terminal, terminal C, is not connected to anything, so you can keep it open, floating, and then between A and B, how much is the impedance, how much is the resistance. Okay, to solve this, we will first consider these star connected resistors inside, and we will convert them into the equivalent delta. So for that, so let me remove these three resistors, and then we will connect an equivalent delta. Okay, so the delta portion I will draw here outside. Okay, this is one arm of the delta, this is another arm of the delta, and this is the third arm of the delta. There will be resistances here, here, and here, 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 and here. Okay, now what will be the value of this resistance, so that this outer delta is equivalent to this inner star. Okay, so how to calculate this resistance? So this will be 2 into 3 plus 3 into 4 plus 4 into 2, 2 into 3 plus 3 into 4 plus 4 into 2 whole divided by the register which was there opposite to this one. Okay, so that is 2, and this is equal to 13. That is this resistance. Now similarly, how much will be this resistance? This will be again 2 into 3, 3 plus 3 into 4 plus 4 into 2. Okay, so 2 into 3 plus 3 into 4 plus 4 into 2 whole divided by the register that was there earlier opposite to this, okay, which is 4. Okay, so whole divided by 4, and this is equal to 26 by 4. That means 6.5. Okay, this is in ohm. All registers in this question are in ohm. And then finally, how much will be this? So this will again be 2 into 3 plus 3 into 4 plus 4 into 2 whole divided by the opposite side resistance which was there earlier, that is 3, and this is equal to 26 by 3. Okay, okay, next let me simplify this diagram a bit. Okay, so this star, I mean this where I can connect here, it's the same point, and this where I can connect here. Okay, because these two are the same point. Similarly, this where I will connect here, and this where I will connect here, and so for this where I'll put it here, and this where I will put it here. Now clearly you can see that these two registers are in parallel, then these two registers are in parallel. Okay, and finally these two registers are in parallel. Okay, so let me get rid of this inside star, which is no longer there now. Okay, now we have to find the resistance from A to B. Okay, so how much that will be? R A B, that will be this two in parallel plus this two in parallel, so they are in series. Okay, so that means these two blocks are in series, and then finally this third combination is in parallel with the rest of the circuit. Okay, so how much is this? This is 6 parallel 26 by 3. Okay, so 6 parallel 26 by 3. Then this is 15 parallel 13. 15 parallel 13, and they are in series, so add them. Then whole parallel with 10 parallel 6.5. 10 parallel 6.5. Okay, parallel. Now if you calculate this value according to my calculation, this is 2.8653. this is in ohm, and that is the resistance between A and B when C is floating, C is open, not connected. Okay, now in the next part we have to find the resistance between A and N. Okay, so for that let me make another copy of the original circuit. Now before proceeding further, I would like to redraw this circuit slightly differently, like what will follow. Okay, so I will remove this, I will move this star portion away from this delta portion, but this point is connected to A, terminal A, so let me connect them like this, and then this point is connected to terminal C, so let me connect it like this, and then finally this is connected to terminal B. So this is B, this is A, and this is C. This is the same as the original circuit, but drawn in a different way. Next, we will apply a delta to star conversion. So for that, I'm going to convert this delta into the equivalent star. Okay, so we will remove this 3 delta connected resistors and replace them with their equivalent star configuration. Okay, now how much will be this resistance? Okay, so that will be 6 into 10 divided by 6 plus 10 plus 15. Okay, so this resistance will be 6 into 10, 60, divided by 6 plus 15 plus 10, 31. Okay, then similarly this resistance will be 10 into 15, 10 into 15 divided by the sum of these three. Okay, so this will be 150 by 31, and this will be 6 into 15, 90 divided by the sum of the three, which is 31. Okay, now I may remove this original delta So let me remove this original delta completely, and this is the equivalent circuit that we have. Now notice that this star point is not connected to this star point. Okay, this may be a common mistake. We may often do this. So this star point is not connected to this star point. Okay, next we have to find the resistance between A and N. Okay, so from here to here, how much is the resistance? Now we will further simplify this. So first of all, notice that nothing is connected to C, so we can forget this. Okay, and then this resistance is in series with this resistance. Okay, so this 4 ohm and this 90/31, they can be joined into one single resistance like this. So let me remove this, and also I'm removing this, and then I put one single resistance whose value is 4 plus 90/31. Then this resistance and this resistance, they are in series, so I remove them and add them together and put one single resistance whose value is 150/31 plus 3. Okay, so this is now joined. Okay, then you notice from here to here, if I call this point as Y, then from Y to N there are two resistors, 1 and 2, they are in parallel. Okay, so let me draw one single resistance after removing these two parallel paths. Okay, so let me remove these two parallel paths and put one single resistance whose value will be this parallel this. So 4 plus 90/31 parallel 150/31 plus 3. Okay, and these are gone. These are definitely gone. Now, how much is the resistance between A and N? Okay, or A N. So this is clearly this 2 ohm in parallel with this path, which is 60/31 from here plus this resistance. Okay, so plus this resistance. Okay, so this and this, they are in series, they are added. Okay, so they are added and then whole parallel with this 2 ohm. Now if you calculate this, if you simplify this, then this is equal to 1.4741. This is in ohm according to my calculation.